Ladies and gentlemen, Mr. Andrew Fang.
Yeah, good morning. Thanks for coming to this session. And in this talk, I'm going to share with you some of the work we have been doing at Yahoo, try to bring the big data processing and low latency together. More specifically, I'm going to walk through with you our effort on the Storm on Yarn. So before I start, and I want to be clear, the work I'm presenting here is represented the work we have done by a group of the Hadoop team at Yahoo. And one of our main focus, as you already heard from Bruno in his keynote speech, is that we are very keen to bring the low latency into the big data processing. For that reason, many of us have been very active in both the Yarn communities and the Storm community. So in my past history, on the other hand, I have been there to spend many of my years on the real-time serving systems. And in last few years, spending time on the online advertisement, personalizations. I actually started my career in some flavor of the application server. I'm really glad to say my friend here who working on the application server days here in this summit as well. So the talk, what I'm going to try to cover is starting with the explain the business motivations, why we try working on this topic. Then we will walk through the technical overviews about the solution we are proposing here. Then in the last portion of the talk, I'm going to touch about the open source announcement we just made, I think it was the last week, about for the Storm on Yarn. Using the slides, I will try to give you a demo per se, and about what the Storm on Yarn enable you to do. So let's talk about the business. Right, as in the Bruno's talk, I think he walks us through the various use cases for you. In here, let me start with our personalization, right? And as you know, Yahoo started as a portal company many years back. And one of our recent efforts at Yahoo is to revamp our Yahoo homepage. The focus of that the launch of Yahoo homepage is try to bring the personalized experience to all of our users. Now, if you look into the center of that page, I mean, this is a screenshot of several months back. You see what we call the today module on the top, and all the content streaming in the bottom of the center of the page. All those information are selected for a particular user. For this particular screenshot here is the article selected for me for that particular day. You see like a lot of the articles about the Silicon Valley companies and about some sports-related stuff. And for me personally, that morning when I wake up, open my Yahoo homepage, saw the article about the Yahoo, stock plus is going up. It was really, interesting to see, Yahoo, as our homepage be able to bring that level of the personalization to me as an end user. So now let's talk about how we really, produce that kind of personalized experience. I'm going to try to walk through with a very simplified architecture, right? So we have online tiers and have offline tiers. In the online tier, basically, is a bunch of the web server type of things, and their job is try to produce the content for the user, right? And what we do is from there, we have the bunch of the servers, and we also have a bunch of the online stores. Inside the online stores, we have the information about the user, about the content. So then, on the other hand, they have the invisibly to the users, they have a bunch of what we call the offline tiers. In these offline tiers, it's the job of offline tier is to process the huge amount of the data about the user activities, about the content, and over there, we will try to perform the processing. At the end result is produce the data for our online store. So as many of you know, Hadoop logically was invented for that kind of purpose. It is an excellent technology, produce a huge throughput for us. So at Yahoo, we love Hadoop. But on the other hand, Hadoop does have some weakness. I think in Bruno's talk, he kind of outlined the various points. In a typical job at Yahoo, you could take a few minutes if your job is fast. And on the other hand, for our sophisticated jobs, take over hours. So that the latency is become an interesting concern when we look into our business side. So more specifically, if you look into the personalization side point of view, right? So there's the two things really play against those latency. One is the user's interest is changing over time, right? In one particular session, let's say before you come to the San Jose, you maybe try to decide where is the hotel you're going to stay, what kind of about the local areas, the stuff you try to looking for. So we wanted to bring those kind of information at that point because you have that interest. We want to bring those information to you right away. Instead, we could not afford to waiting for another day, a few hours later, to give you that information because at that point, your interest may have moved on. Then the second area is because the content. There's a content, think about the break news. So those news showing up so quickly, you do not want to spend too much time to processing those content. You want to bring the content to the user right away. So from that point of view, the latency is really critical from personalization point of view. So for that purpose, in the last several months, one of our main efforts at Yahoo, the offline tier, is the introduction of the low latency processing capability. So the low latency processing capability is complementary to our batch capability provided by the Hadoop. So thinking about it in a typical time, this low latency processing is processing the user events or the content. So thinking about it, the user, you are searching for a particular hotel or some type of the San Jose hotel in the Yahoo homepage. You do a click, right? You try to search for it. At that point, and we wanted to look into the event activity you just performed, and so by our low latency processing framework, then try to apply on top of the profile information we already have from our batch processing, on top, bring those two pieces of together that will enable us to get your latest interest profile of you. Same thing for the content, right? So with that, what that enables us to do is update our online stores within seconds of latency instead of minutes kind of latency, right? So that's really very important for us. And ever since we launched off our homepage and several other properties, we have seen a significant improvement of the user engagement due to the new introduction of low latency on top of our batch processing framework. So in the nutshell, what we needed here is a design pattern that enable us to combine the big data and the low latency together. And they could not be completely separate because there's a lot of data exchange needed to happen between the batch and low latency. So that's, I think, to us, this is an important design pattern a group of Yahoos have been working on in the last several months at least. So on top of the use case I already mentioned for the personalizations, and there's many other use cases. And in Bruno's talk, for example, he walks through the advertisement budgeting forecasting, right? So over there, same thing. You wanted to advertisers specify how much money they're willing to spend for a given day. We have large number of the machines that exist. So we want to using the batch things to compute the model based on the historical information, the architecture. Then we want to use the low latency framework to make sure we never overspend advertisers' budget. So with this kind of things, we start to see a lot of the interesting business implications by supporting this design pattern at Yahoo. So once we realize this design pattern is important, now then the question will be, how are you going to support it, right? So that's why we want to, let's walk through the technical proposals that we have on the table. So I think as you guys already heard in this is a keynote speech, one of the biggest things that we believe is one of the upcoming very important piece of technology is the Hadoop 2.0. More specifically, we love the resource manager YARN. Because what YARN enables us to do is enable us to support the MapReduce and other paradigm. As I mentioned in the early on, because if our design pattern demand us to have that capabilities. So from Yahoo point of view, we believe YARN will be a key technology for us to provide that capability. So that's the one key piece of technology Yahoo believes in. And as Bruno mentioned, Yahoo tended to play way ahead of the other players in the industry. So now, as you guys heard, the YARN is still in alpha, or maybe in a few days in beta. Guess what? At Yahoo, we already put YARN in production or tens of thousands of machines in all of our production machines. It has been in action for several months. So you will hear all in tomorrow's session, my coworker, Bobby Evans, is going to share with you of our deployment experience on YARN into our production stuff. So that's I think we believe it. We actually put it into use. Then the second piece of technology we believe is important is this thing called Storm. Storm is an open source technology, and it's designed for leveraging a distributed computation powers to process events in a real-time manner. So here's the diagram over here outlines the basic concept of Storm. In the Storm, what you're going to do is you deploy your applications like a daemon process on a collection of machines. Your Storm application is going to be running there for a long time. So then they're going to communicate with each other. There's two types of application processing units. One is called sports, that's in the front, and the others we call the boards. Sports is the one that emits the events. And the boards are the things that are going to take the incoming events, doing some processing. And some of those boards may even emit the outgoing events. So you could compose whatever the DAG as you like. It's your application's job to compose the DAG. So if you compare with the Hadoop, MapReduce, there's two differences, right? One is in the MapReduce, there's a map and a reduce, that's it. And in the Storm, we have, you create the DAG of your processing unit as complicated as you want. In this diagram here, I have the two tiers, or here I have the 3 tiers. You create as complicated as you like. Then the second difference for the MapReduce is that in the MapReduce, you need to, whenever you need to do the job, you need to launch your process. From there, you're going to do the job. And in the Storm is the case, your application is already pre-launched, waiting there for the events to happen. Whenever the event happens, we will processing right away without any delay. On the other hand, there are a lot of similarities, like compared with the Storm and Hadoop. One of the similarities is it's designed for the distributed processing. So it leverages all your resources available in your cluster. You could decide to say, this piece of the processing unit, I need 5 machines to do the work. And another piece, I need 10, another 100, decide whatever you want. So the Storm will allocate those resources for you. You do not, then provide whatever the parallel computing it needs. And another side is the failover, right? Once you have lots of machines, some of the processes are going to fail. Storm will take care of you. So from that point of view, just like the Hadoop, Storm is a distributed computation paradigm tried to produce the very low latency for you. So you could model many types of the applications in the Storm. Logically, say, as long as you could say, my application is processing and streaming of something. That something could be, user activities at Yahoo, add beacons, content feeds, social feeds, whatever you like. So with those two pieces together, we start, see at Yahoo, we started, once we believed in Yahoo, we believed in the Storm. At Yahoo, we started looking into saying, what we can do enhance Yahoo, what we can do enhance Storm. That's why you guys, some of you must have seen a lot of activities from Yahoo group, and we have been making the contribution to the open source community. On the other hand, we have been trying to put the Storm in use in the last several months. So here is a typical ways at Yahoo we use Storm in our environment. So instead of create a separate Storm group to manage your Storm cluster, we decided to say, we have a Hadoop grid team. We using those grid run Storm job. So here's how we're going to do the work. So as an application developer, let's say our right media, advertisement team, or personalization team. What they're going to do is go to our grid gateway. Over there, you're going to deploy your Storm application. Once the application gets submitted, that application is going to be landed in this thing called Storm Nimbus. Storm Nimbus essentially have the similar capabilities like the MapReduce job checker. It is the control center of the Storm framework. From there, Storm Nimbus is going to decide what's the set of machines that we're going to use for that application. It makes its decision known to the whole cluster by update some state in the zookeeper cluster, the set of the zookeeper we have on for the Storm. From there, the machines will be notified, and they will install the application that is submitted by our application owner. Then from that point, your Storm application will be running there for a long time. Because at Yahoo, we deploy this Storm application in the great Hadoop environment. So as a result, we enable our Storm applications to access various Hadoop resources. One of the key things, as I mentioned in the design patterns, was the Storm applications needed to access the data from the MapReduce. In many of our applications, Storm application now, we use HBase as the storage, the data exchange between the MapReduce and the Storm. On the other hand, remember we wanted to our great ACE team be able to manage our Storm cluster. So we decided to have our Storm cluster be able to be monitored by our existing grid monitoring systems. So that's basically, kind of the cluster we have been deploying. And as Bruno mentioned, we have over a few hundred nodes in our production at this point. And currently, actually, it's not a single cluster. It's a few clusters. And some of the clusters are handling the everyday users events. In Yahoo's case, we are talking about the 130,000 user activity events per second. So this is kind of cool, right? So you could, using this, copy this patterns to deploy your things. And at Yahoo, we see lots more application actually is coming up. They say, we want my Storm, your Storm. I do not want other guys Storm applications about my Storm applications. And we could keep building this kind of using the Storm isolation scheduler and several other capability to do that. Then we say, maybe we could do an even better job. We are a technology company. So that's why we decided to carry on the work of the Storm on Yarn. The main focus of the Storm on Yarn is we wanted to come up with very simple ways for our Storm application developers to launch their clusters. We do not want to go through days of work to set up a cluster. So with the Storm on Yarn, what you're going to do is go to our grid gateway, run a single command line function, Storm Yarn launch. In that, you're going to, and then you're going to say, give a configuration file. What's that? In that configuration file, what are you going to specify? Logic, what are you going to specify is the size of your cluster you want, and the memory or those other resources you're going to need for your containers. So with that single command line, you will launch your Storm cluster in a distributed environment. You do not need to worry about anything else. Then under the cover, what's going to happen is that we will leverage the Yarn resource managers to allocate a container for our Storm master application. So from there, the Storm master application gets launched. When the Storm master application gets launched, it's going to set up all the things needed for your Storm cluster. So to start with, it will launch the Storm Nimbus process. That's the control center, as I mentioned. Then the other side, we will launch the Storm UI servers that enable you to do some management of your Storm cluster. Then, as you mentioned, you said you needed the 10 machine clusters. Then we're going to launch all the supervisors, find those 10 machines, launch those 10 clusters. Over there, we launch the thing called Storm Supervisors. So with that, your Storm cluster is up running, right? To make your life easy, so once you get launched, we will give you an ID about your application, what we call the application ID. So that is your secret. You keep that secret, do not give your friend, okay? So once you have that secret, now you could using that secret to manage your Storm clusters. Again, you're going to using our Storm Yarn method. In it, there are several basic administration capabilities we provide. We are showing one of the first one you want to care is, at the beginning, you may launch a cluster of 10 machines. So you say, my Storm application really become popular. I need more. Then you're going to say, I add another 50 machines for my Storm cluster. You just do that. Then what's going to happen is the source command going to send it to our Storm master. The Storm master going to find those additional 50 machines for you, added into your cluster. And then another method you're going to use is the get Storm configuration. Because you need because this cluster is launched dynamically, in order to launch your Storm topology, you will need information like where is my Nimbus server, where is my UI server, those other things. So get Storm configuration is the one give you that capability. And certainly we will enable you to start a process, stop process, those things, right? So once you do that, once you have all those stuff, then what you're going to do is just using the standard Storm method to launch your topology. So your Storm jar, your application jar, that's it. Then under the cover, it's going to go through the standard Storm process, talk with the Nimbus, launch find the supervisors, set up your application for you. At that point, everything is running, right? So that's the one side of the Storm OEM. What we try to aim for is to make your life really easy to launch your applications. Then on top of that, we have been, because we are Yahoo, we want to worry about our data security, all those stuff. So with that, we have been active to enhance the Storm software layers with the security capabilities. So for that, in the recent releases of the Storm, you might notice that from Yahoo, we contributed to the authentication. We introduced the authentication layers in the Storm. We introduced the authorization and those other things. And currently, we have released all the basic capabilities for the authentication, authorization, and audit to the open source. And we will release more stuff, such as Kerberos authentication to the community very soon. So that's our vision of the things. Now we say, we could keep working on it by ourselves, but why don't we just leverage, open this thing up to our, bigger community? So it's kind of following our philosophy, established several years back about Hadoop, right? In the Hadoop, we did the work with open source, then get the large room of you engaging it. So same thing we wanted to do about the Storm OEM. So the last week or so, we announced our Storm OEM code on the GitHub at this point. This is available for you. This is logically is the early access code. We still, if you notice, we are keeping working on it every day, right? And this is a Storm OEM code is available under the Apache license. And we hope someday we will move to the apache.org. But at this point, we feel, we just want to get the ball rolling. And on the other hand, as I mentioned, the reason we open source, we wanted to get the engagement from the community. So that's why we are very keen to get your contribution in there as well. And I'm very glad to see some of our community already started contributing to it. So now you will wonder, so what can you do with it? So I think I will encourage you to check out our code, type one command, Maven test for the developer. This is just standard thing. Check out the code, do the test. Then you will see as part of the Maven test, you see the execution of our Storm things. The first thing is, as a part of the test, we are launch a cluster. Launch a cluster using Storm launch, and you see the UI. You could using the Storm UI tools to see what's going on. Over there, you have a Storm cluster up and running. Then you're going to get your Storm configuration. Then using the standard Storm jar method to submit your applications. You see over there, one of the topology is launched. Then you could dig it to make sure it's actually running, right? Over there, within a few seconds, there are the tens of thousands of requests get processed in your Storm topology you just launched. So once you have fun with that, then you could say, no, I'm done with it. We will kill your Storm topology, and then shut down the things. Everything is clean, as nothing happened. So this is the kind of give you the flavor to demonstrate, as a developer, what you could do, right? To demonstrate this the storm yarn is real, you could do something about it. Then once you have those, then now let me talk about how you're going to reimagine you're going to deploy in your production environment. So first thing you need to do is make the storm software available in your Yarn cluster. What you need to do is using this Hadoop method to put the storm zip into the HDFS directories. Once you do that, then later on, all the job is just the same as we just saw in the Maven test. You launch your, using the storm yarn, launch your application. As a result, we get your secret application ID. And over there, you get your configuration file stuff for your storm clusters. Launch your application topology. That's it. So anyway, so that's the basic, the coverage about our storm yarn effort. And in the nutshell, we believe it is a very important design pattern to bring the big data and the low latency together. So we have an elephant and cheetahs that come together, sitting in the same room, exchange the information by our storage system. And then we believe the yarn is a very important capability to enable us to do that. And as in this talk, we mentioned the Storm. We believe Storm gives us the, support a large number of the design patterns Yahoo care. Assuming many of you may care. So that's why we launched the Storm on Yarn last week. And on the other hand, as mentioned in Bruno's talk, we also developed another Yarn application that enable you to run Spark applications on Yarn cluster. So that's the Spark on Yarn contribution from Yahoo. With that, I think I'm going to take some questions. Thank you. No questions? Is there microphones or something there? Some kind of harder to hear. Okay, if you guys have any questions, just stop me. I'll be just waiting here on the off the stage. Then we will go from there. Thank you.